Broadcast is now starting. All attendees are in listen-only mode.
Good morning. Thank you for joining us today for part 11 of our digital GD&T series, a QIF case study maintaining the digital thread from OEM to supplier with guest presenter Ryan Gelotte from Action Engineering. My name is Ben Reese. I'll be your moderator today. As a note, today's event is being recorded and the recording will be sent out tomorrow morning. Throughout today's event, please feel free to send in questions using the question box in your GoToWebinar interface. There's a short survey at the end. Please take a moment to fill it out and give us some of your feedback. We really appreciate it and use it to improve our webinars as we go forward. If possible, I recommend you use the speakers on your computer as you will get the best sound. As a highlight, I want to remind everyone that we are coming out with a new product, 3DCS for SOLIDWORKS this year. We're going to be showing a preview webinar next month, July 25th, and we're excited to be showcasing this new integration of 3DCS, now fully integrated in SOLIDWORKS. In addition to next month's webinar, 3DCS for SOLIDWORKS, we'll also be having a webinar on design of experiments in August, and the X-Form DLL, which contains a number of different move routines. We have additional webinars in October, November, and December. So please take a look at the registration page and watch our blog for those topics. In the survey after the event, if you have any particular topics you would like to see in our webinar series, please send those in to me. We do use our client suggestions for many of our webinar topics, as we want to showcase what you want to see. And these are really good ways to see a deep dive, an example model, or almost a free training class. Speaking of training classes, in August of this year, we're excited to be hosting an open GD&T training class. This will be MBD using modern GD&T, a course presented by Action Engineering here at the DCS headquarters in Troy, Michigan. This is open to all DCS clients, so if you're interested in it, just go ahead and note that in the survey after today's event, and I'll follow up with you with some additional information. There's no need to sign up right now for the class. Just let me know if you're interested in staying informed, and I'll keep you up to date. We don't need an official buy-in until 2 to 4 weeks before the class itself. Now this class, the course overview, we'll be going over how model-based definition, how to use GD&T for model-based definition, including some of the basics of GD&T. And Ryan Gelotte, our guest presenter today, will be the instructor for that class. So coming back to our instructor today, I'd like to welcome Ryan Gelotte of Action Engineering. Ryan is a model-based enterprise analyst for Action Engineering, and he holds degrees in both plastics engineering technology and a mechanical engineering technology from Payne State, Erie, the Behrend College. Ryan's career over the years has included a focus on all aspects of plastic part design and manufacturing, including mold design, as well as expertise of PTC's various CAD and PLM systems. In fact, Ryan started his career as an applications engineer for PTC from 1998 to 1999, and over the years has provided training, support, and consulting services with PTC's products for several companies. His experience in engineering systems, product design, and manufacturing have been instrumental in preparing him for the many challenges that come with implementing a model-based enterprise. He enjoys the many challenges inherent to the engineering discipline and thrives off of finding new, better ways to accomplish superior results, both in engineering and manufacturing operations, by defining model-based processes. So at this time, I'd like to welcome Ryan Gelotte. Ryan, I'm going to be passing the presenter over to you if you'd like to say hello.
Hello, thanks, Ben. Great. So you can hear me, I'm assuming?
Yep, you're coming in strong. If you want to turn up your sensitivity a little bit, that'd be great.
Sure. Okay, is that better?
Excellent.
Okay. Thank you, everybody. Thanks for the opportunity to share some of the goodness of NBD and the QIF Quality Information Framework. So today I'm going to talk about model-based definition and the challenges of moving NBD from an OEM to a supplier. It's a rather chaotic process sometimes. So we're going to talk about, is there a ringmaster in the circus, and we're going to really show how QIF can really enable this this handoff. So just a little bit about Action Engineering. We are a team, a very diverse team of pragmatic experts. We all complement each other very well. Implementing a model-based enterprise is very difficult, and it takes a village. And we really pride ourselves on focusing on not just the tools, but also the people and the processes and the standards as well. So we have a very diverse team here that can focus on all aspects of implementing a model-based enterprise.
So as we get started here, I have a quick poll just to help Ryan understand what kind of CAD systems and background some of you have. So I'm putting this poll out right now. Please take a quick moment and answer. I'm going to give everyone about 2 to 3 minutes. Okay, wonderful. Looks like we won't need that long. I appreciate everybody being quick on that. All right. Once we hit the 1 minute mark, I'll close it and show you all the results, as I'm sure you might be interested as well. Looks like we have a majority of CATIA users, CATIA V5 and 3D Experience. That's kind of to be expected. The majority of DCS users are CATIA, but we have seen a sharp rise in NX, especially with its connection to CAM. Some Creo, and of course other, which is probably Inventor, AutoCAD, that kind of. Thank you very much. All right, so Ryan, that frames a little bit from where our current attendees are coming from.
Okay, thanks, Ben. Thank you. So interesting results, and nice diversity there. Good to see some Creo users in there, as well as some NX users. To that point, we also really look at a model-based enterprise from a CAD agnostic standpoint. Right, we look at CAD as a tool to achieve a model-based enterprise, and especially when we're talking about supply chain and handing off from an OEM to a supply chain. The reality is not everybody's using the same CAD system, so that's good that we have some diversity here. Moving on, just some of our methodology here. I'm not going to read all these verbatim, but this is just some of the work that we do and some of the services that we provide. Again, our big focus is on all 4 legs of a big cultural change like this, the people, processes, standards, and tools. So there's just a little bit of information about what we do. We serve several industries, so we do have a diverse customer base. So you can see we do have some customers in representing a lot of the major industries out there. And then as far as industry leadership, we're involved in standards committees. Actually, Jennifer Herron, the founder of Action Engineering, was the Y14.46 chair which is the chair for digital additive manufacturing, digital design for additive manufacturing. We're also on the board of directors for the Digital Metrology Standards Consortium, which is really responsible for creating the Quality Information Framework Standard, and we also have presence on the MIL Standard Committee. Myself, I'm actually the Model-Based Enterprise Technical Committee Chair for PTC User, which is a nonprofit organization that provides a voice of many PTC customers to PTC. And we also work with Autodesk on their MBD standards and practices. And finally, we have a conference in the last slide in this presentation. You'll see about our conference in October called 3D Collaboration and Interoperability Congress, where we really get a lot of attendees from that use all of the major CAD tools. So it's nice to get all of them in the same room and everybody share their pains and successes from different points of view that are using the different tool sets.
Ryan, is that your CIC?
We also have go ahead.
Is that the CIC conference?
Yep.
Okay.
Yes, that's the CIC conference, correct. Yep. Yeah, CIC is a lot easier to say than Collaboration and Interoperability Congress, so that is CIC. And then we also partner with Purdue, the Purdue PLM Center on workforce development. Right? Sometimes it's good to tap into the universities, and we really are believers in the model-based enterprise and would like to see the education on how to implement a model-based enterprise spread into the universities and even trade schools. And then our other partner is GeoTol, which is, yes, I am a GD&T trainer, but I really have my mentor, Scott Newman from GeoTol, who we work with, and actually we developed the class that Ben mentioned earlier in August with the collaboration of GeoTol. So we handled the MBD training material, and Scott and his company helped create the geometric tolerancing material. So that's a really good partnership that we have with GeoTol. So enough about about us and the salesy type of stuff. Let's get into the fun stuff. So this is a high level sort of setting the stage, right? The opportunity for model-based enterprise, if we just look at the world of how things are designed and made today, it's pretty common across all industries. A customer or an OEM is going to go to a supplier and say, we need this, and that supplier can design a concept, and if that concept is acceptable and shows promise, the customer can initiate further activities and get into a more detailed design process, right? At which point your design organization is going to hopefully collaborate earlier and more often with those responsible for making it. There's still a lot of over-the-wall type of processes when it comes to handing off designs to manufacturing. And, in either case, you're going to get somebody in that supply chain or within internal manufacturing that are going to give you some feedback. We can't make this as it's designed, and you're going to have to make some changes. And you can go through that loop several times, right? It depends on the complexity and your internal processes. But eventually, you're going to get it to a point where we're ready to start building something. So we'll go ahead and design some tooling, build some parts, assemble them, then pass it over to quality engineering, and they're going to inspect it and test the parts. And hopefully everything meets all the requirements. You're going to deliver it to a customer and then sustain it. And then eventually you're going to decommission that part. So in a 2D drawing-based world, right, there is, when we're relying on 2D drawings, I think everybody who's interested and has done the homework around MBD and have been introduced to MBD understand all the ambiguity around a 2D drawing, because it's a two-dimensional medium trying to describe and communicate something that we make in the real world, which is 3 dimensions. Right? So we do have to deal with a lot of that ambiguity, and geometric tolerancing is a 3-dimensional language, which really removes a lot of that ambiguity, which is why there's such a synchronous relationship between model-based definition and geometric tolerancing. Right. We also have a lack of traceability. So in a drawing, paper-based world, there's handoffs of information through each of these steps. It's not digitally traceable, so there's a pretty large lack of traceability there as well. And there's a lot of slow throughput, right? And we're relying on disconnected processes where information can sit there and wait for days or weeks at a time before somebody really gets to it. So that can slow the process down all along this process. And because it's not digitally connected, right, there's a lot of data reentry around this process. So that also, humans are not perfect and can incorrectly input information, which can also cause add a lot of risk and error proneness. So by implementing a digital thread or the model-based enterprise, we can remove that ambiguity. We can remove that lack of traceability by implementing digital workflows, whether it's through PLM or ERP systems. And we can increase the throughput, right? So we're giving these people that need to do something, that information digitally. It's much more efficient, and then we're reusing data, right? We're not re-entering data since this is all digitally connected, which removes a lot of that error. So that's sort of the 1,000-foot view here of, you could really say a lot of digital processes, but we're really talking about the design to manufacturing process here. This is our digital thread for a model-based enterprise. So when we talk specifically about the supply chain handoff, there's a lot of processes, right, riddled with all of that ambiguity, lack of traceability, and error proneness, and it can be rather chaotic, right? In fact, if you're a lot of people throughout this whole ecosystem have to juggle a lot of things at one time, right? Because everything's disconnected. So, there's most likely going to be some balls dropped in that whole process. So we want to look at a model-based enterprise and how do we tame this circus, right? So this manual supply chain handoff, right? Today, there's drawings, models, process requirements, specifications, RFQs, a lot of documents and artifacts that are passed off manually, whether it be through email or supplier portals. And then the supplier is going to send information back, right? So there's a lot of this churn that happens in this supply chain handoff. In fact, on average, 6 to 20 data exchange handoffs, and that's on average. It could be more. If you're really efficient, it could be less. But there's a lot of handoffs here. And most of those handoffs rely on human reading and human interpretation and then reentry of data. And if we talk about model-based definition, right, if there's OEMs that have successfully implemented some model-based definition practices, the majority of the time the suppliers will take that, and maybe the first thing they'll do is create a model that they can create a drawing from, or take the model that they receive from the OEM and generate a drawing so that they can push through their environment, right, because they're still very much in a drawing-centric world. So that's the reality of what we're faced today, right? And there's a lot of actors in this whole circus, right? There's a lot of people involved, and nobody wants to go and look at just one of these acts, right? We go to the circus to really enjoy what everybody's doing, and if any of these people involved in the handoff can't reap any benefits from a model-based enterprise, then we're not realizing the whole value, right? So we need something to tame that circus, which is model-based definition. So let's get into that a little bit. So the supply chain handoff needs two big things, right? It needs this traceability, right? So we need a digitally connected handoff here. And it needs model-based definition. And we're going to dig into that further of why the supply chain needs model-based definition to tame this circus. And we're going to really show how the quality information framework can really take our model-based definition efforts to the next level. So really what we want to do is make model-based definition valuable for everyone, right? We can implement model-based definition within the OEM, right? They can receive some value there as well, but if the supply chain's still going to recreate drawings and continue with their drawing-based practices, the OEM's not getting the full value of model-based definition because a big reason that we're doing this is to become more efficient and at the bottom line reduce costs and save money, right? So we need to show that the supplier can become more efficient, the supply chain, and save money, which in turn is going to save a lot of money for the OEMs, right? And a lot of times today, just because of that manual handoff and recreating the drawings, there's suppliers that may actually increase their quotes and increase their costs because they don't know what to do with model-based definition. And that's what we want to avoid here. So we need to, in order to do that, we need to adopt open standards like QIF and ASME and ISO, whatever standards you might be looking at, right? Because not everybody's using the same tools and everybody's processes are different. So these standards are going to be critical to being able to pass that information from the OEM to the supplier and be able to work with it. We have to adopt model-based methods, right? So it's not just about the CAD model. We also have to change our processes to be able to leverage that CAD model. And move to advanced manufacturing and quality methods that can reuse your MBD, right? That CAD model, or a lot of times we call it a digital twin, has the opportunity to really enable a lot of advanced digital manufacturing and digital quality methods. Right? So just implementing model-based definition in design without tying it to digital efforts in manufacturing and quality is kind of synonymous to recruiting a 5-star quarterback but you don't have any receivers. Right? What's the point? Right? So we need to enable these manufacturing and quality organizations to reap the benefits of model-based definition as well. And model-based definition is really the cornerstone of the model-based enterprise. Our model-based definition that's the thing, right? That's the artifact. That's the data that can be reused, and we need to make sure that our model-based definition is very solid and adhere to those open standards so that everybody can reap the maximum value out of that. So let's just talk about model-based definition. What is it? Right? We look at model-based definition in 4 parts. It's something that designers have been doing for years. You create 3D CAD geometry. That's what we all as CAD jockeys like to do. We like to model stuff. Right? What we probably don't like doing is taking that geometry, throwing it on a floor mat, and creating a drawing so that everybody downstream can still do their job the way they've been doing it for decades. So enter the big change for model-based definition, which is 3D digitally associated annotations. So these are your dimensions and tolerances and notes that aren't just dumb text that somebody's going to re-enter, but they're actually associated to this 3D CAD geometry to maximize the reuse potential of our models. Not everything needs to be defined in a 3D space. There's metadata that's going to very much describe our parts. So we're going to include the metadata in this as well. And then the 4th part of MBD is the presentation states. Right? This is the model-based definition equivalent to 2D drawing views. Right? These are meant to tell a story for the person that's interpreting or receiving a model-based definition package. It's not really machine readable. The presentation states aren't going to do a whole lot with enabling downstream technology, but unless we're working on a lights out factory where there's no people working in it, there's going to have to be some human visibility and human interpretation needed. So this is actually very profound, because looking at 3D model-based definition views is a much less ambiguous way of communicating what a part looks like and what its requirements are than in a 2D drawing world. A lot of us take for granted the ability to look at 3 or 4 orthographic projection views and process that in our head to get an idea what this part's going to look like. Right? That's a trained skill that takes a lot of time to develop that. Right? When you're looking at a 3D representation, that skill is no longer necessary, and it's a much less ambiguous way of communicating that, and it's a very profound change that I think a lot of people really appreciate. So let's talk about how information flows throughout the life cycle of a product. Right? So we really, there's been for I think a long time this in model-based definition world, this kind of drive to create one model to rule them all, for kind of a cheesy analogy there, but that's not really feasible in a lot of cases. Right? So today, if we look at how information's passed between those 3 organizations, right, your design's going to have all of that product definition information, and it may also actually in a 2D drawing have a lot of information that is not necessarily to define the product, but information that is necessary for manufacturing and quality. So that drawing really becomes a dumping ground for all 3 of these organizations. And then people can interpret and receive those drawings, whether in a 2D PDF or paper drawing, and they can now get the information they need off of those drawings and re-enter it into whatever systems or processes that they need to perform to accomplish their goals. So really in a model-based world, we want to not try to shove everything in one contextual data package. Right? And it's the first time I've mentioned the word data package. Model-based enterprise isn't just about the 3D CAD model. It's really about the CAD model and any artifacts necessary to define that product, as well as any derivatives such as step files or QIF files. Right? It doesn't need to all be one single file, is my point. Right? But there is going to be a need for manufacturing to get out of their 2D CAD and 2D drawing ways, which means for a lot of organizations, and especially in the supply chain, we need to introduce 3D CAD and 3D modeling to the manufacturing supply chain. That can be kind of a profound cultural change in itself. Right? But if I'm not given a drawing anymore, I'm given a 3D model, I'm going to need to be able to do 3D modeling myself to accomplish and reap all the benefits of model-based definition. There's also going to be a need for a quality model, right? And in what we're going to talk about today, it's going to be like a QIF derivative. But you're going to need some sort of data package that is used. And you notice that there's a lot of the 4, or actually the top 3 here, shape, dimensions, tolerances, and information, are common across all 3 of these organizations. Okay, so the quality organization is still going to need the shape and the dimensions and tolerances to enable creating more modernized bills of characteristics, measurement plans. QIF has a huge impact on CMM programming to really greatly streamline that process. But then you also need a data package of quality where your measurement results can then carry this information back to manufacturing and design so that they can improve their future designs, existing designs, and improve their manufacturing processes. And so this closed loop environment, I mean, that's what we're all after, right? We're all after a digitally connected world where we can enable all kinds of things. The Internet of Things is a big buzzword today, right? But if we're talking analyzing big data to do great things, we can't do that without normalized data. So model-based definition is going to enable a lot of those things, both in design and manufacturing. So we also, by contextualizing this data in those different buckets, we can be much more tactile and strategic in how we pass information off from an OEM to our supply chain, right? So we don't necessarily need to give away all of our intellectual property. We can just give our supply chain the information that they need by contextualizing it. Our tier 1 suppliers are going to have suppliers as well, so they can create their own data packages to pass on to their tier 2 suppliers, and so on and so forth, on up to just buying parts off the shelf. So by contextualizing that, we can really streamline and be much more strategic about how we pass information off across the supply chain. So let's talk about the star of the circus, right? We really put the characteristic at the center of all this. The characteristic is, from a product design sense, it's a characteristic of, it can be a tolerance, it can be a note, it can be a lot of things, but it's some characteristic of our design that, or our digital product definition, that really meets some product form, fit, or function requirement. Right? In manufacturing, the characteristic is something that it's a requirement for what they're making. And in quality, they're probably the closest thing we've had to a ringmaster in this circus for all, for ages, because they're the ones holding everybody accountable. The OEM's quality is holding both their product development organizations and their supply chain accountable, and the supply chain's quality engineers, quality organizations are holding their manufacturing organizations accountable. So by putting the characteristic, right, in this case it's a flatness tolerance, and creating a digital thread, we now can build trust in the models and add value in these models in these 3 different organizations. And it's traceable and it's authorized. Right? And the quality organization can really handle characteristics both from design and from manufacturing. Right? This is product definition characteristics. Manufacturing can create their own models for in-process type of definitions, so we can make sure that we're finding problems at early operations in the manufacturing process and stopping them from proceeding to other costly processes, only to find that they're going to be scrapped at the end. Right? So QIF is really, this is where I'm going to start getting into the value of QIF and explain a little bit more about QIF. So Ben, I think you had another poll question maybe at this point?
Yep, it's a great time for it.
Yep.
Let's just see if, we're just curious to see how many people have heard of the QIF standard or are familiar with it. This will help Ryan kind of set how much he needs to introduce it. All right, so that's, again, about 50%. Looks like the majority of our attendees have either never heard of it or have heard of it but aren't very familiar with it and its use. So yeah, an introduction of QIF, and that's very good here. I'm just going to give it another 10 seconds. All right, great. Let me share with everyone real fast. So you can see the majority, 82% of our attendees right now have either heard of it but aren't familiar or have not heard of it before. So So this will be a good overview.
Excellent. Yeah, and we'll follow up with a link to the DMSC and the QIFstandards.org website. You can definitely get a lot more information from there than what I'm going to present in this short presentation. But let's go ahead and proceed with how this, what this looks like. Right. So the traceability is really enabled by what we call a quality persistent identifier, or a CUPID that we so affectionately call it, which is really adopted the UUID standard, which is an ISO standard adopted by Microsoft, and Microsoft is known as the GUID. It's essentially a social security number for a characteristic. Right? So if we talk about this, we have a source model, and just kind of to rehash what I was talking about here, this characteristic has our three primary machine readable components of MBD. It's a flatness tolerance, so there's our annotation. It's associated to a geometry in the CAD model, right? And then it can also have metadata, right? In this case, it's really the tolerance of 0.004. That's the value. That's the information. So it has the data, the annotation, and the associated geometry. That's what makes up that characteristic, right? And when we talk about this from the QIF standpoint, we can take these characteristics and create it, or take these MBD models and generate a QIF that is going to give us a bill of all the characteristics, right? That bill of characteristics can automatically populate an AS9102 first article inspection form, or any other type of quality inspection plan, right? It can also capture inspection results, right? So it's not just a derivative file, right? A lot of people get kind of confused about QIF. It's just another derivative, like a step file. Well, that's not really the case. It's the CUPID that sets it aside from what a step file is. Every time I use a QIF file, that CUPID is persisted every time we pass it off to another person that needs it. Right? So if I create a QIF derivative of a CAD model Rev A, right, the next time I create that QIF derivative, those characteristic IDs aren't going to change, the CUPIDs, right? So then when I pull it into, let's say, a CMM machine that's inspecting it and reporting results, the CUPID remains consistent. So then we can populate, report these inspection results either into inspection reports or even publishing them into a database like a quality management system. Right. And then we also can take derivative models such as step models that can be used and walk through the process to create their in-process machining models, tooling models and fixtures, model-based work instructions, like animations, and just generic work instructions in general. And then CNC programming to machine those in-process models, and then finally machine them and assemble them. Right? So that characteristic is carried through both of those downstream silos of manufacturing and quality, all derived from the product definition. Right. So moving on, this is a slide that we haven't really talked about it much at this point, but anybody who's worked with a model-based enterprise project or initiative, right, if we're now deriving data and we're replacing a static 2D drawing that can be printed and viewed with, say, Adobe Reader, if it's a PDF, that is the traditional authoritative document. If the authoritative document now is a 3D CAD model, that's a digital document. It needs to be validated. Right? We need to make sure one of the first challenges in overcoming the cultural resistance to model-based definition is getting everyone to trust the model. Right? The first time that a machinist gets a model that just doesn't match the drawing, in a 2D drawing world, that's, it leaves a pretty salty taste in somebody's mouth. That drawing is the source authority, but I just wrote a program to a model that doesn't match it, and I had to scrap my part. So we need to make sure that as we go throughout the life cycle of products, that as we're defining the design and the product definition, that we're checking the tolerances against the standards, the annotations, all that against the standards. And then during the release process, this is really important. And I know, like, there's OEM people on the call, validating your derivatives is an absolute must, right? Because if you don't validate your derivatives, you're adding some extreme risk, and most likely the OEMs are going to require you to validate them anyway, right? Including our QIF derivatives. So let's get into let's show you, I'm going to show you how this all works. This is an actual project I worked on last year, somewhat genericized. I removed the CAD tools that we used, CAD A, and made it more generic rather than pointing out what we actually used. But any CAD software with the third-party plugins that support QIF should be able to do this. So we have a native CAD model at the OEM, and they're going to generate their derivatives. And for their entire digital product definition, in addition to the CAD, there could also be specs and procedures, right? And some of those specs could, dare I say, even include 2D drawings of like standard, features like O-ring grooves and things like that. It doesn't necessarily mean 2D drawings have to go away completely, because that's eventually we all hope that they will, but there still may be a need to keep some 2D drawings around for standard, industry standard design features and things like that. So the OEM is going to then generate a data package, right, that defines their product digitally. It can be a 3D PDF with the derivatives, QIF and step files. You may even include the native CAD file and those specs and procedures. And that's what's going to be passed off to the supply chain. But before we get to the supply chain, the quality organization within the OEM is going to can create a bill of characteristics to populate, say, a first article inspection form or a quality management system. Right, so that all can be digitally passed into those downstream processes. Right, so there are several QMS systems out there. You might be using DCSs, 3D CSs, but the idea here is that we're able to reuse that product definition data, avoid that data reentry, and populate those quality management systems. Then from there, we're going to send the data package over to the supplier. Right? For manufacturing, they can use STEP. Right? I say generically, I don't call out STEP or STEP AP242 because it depends on what software and what tools they're using, whether they can leverage STEP AP242 or not. Right? But the idea here is they get the STEP file and the geometry from the OEM, and they can start building their manufacturing models. Right? A model for operation 1, a model for operation 2. Those models then can be input into a CNC program or a CAM software and generate CMC programs, which are then used by the actual machines that cut steel to generate these in-process models. Right? So we have an in-process item. Now, at the same time, the supplier can create their own characteristics for their in-process models that they need to generate CMM programs from. Right? So depending on which CAD software and CMM programming software they use, it could work with the native CAD software, or it could actually use a QIF derivative as well. And it's really, this is where the value for quality comes into play, because those machine readable characteristics that understand the geometry, the programming software can set up moves for the probes based on the geometry and the angles that it needs to be programmed to, and the paths to avoid interferences and things as such. And so it really can greatly automate that process. Okay. And there we have, we're going to then take the actual physical part in the program and we're going to inspect it. At the same time, in this particular case study, this supplier actually, their final cut, their final machining process, they actually, to maintain that full digital thread, were able to use the native CAD geometry from the OEM to generate their CNC program, right, which is then going to end up with that final part. And we're going to take that second to last operation part and put it in a machining center and get our end item. And at the same time, we can pull in the native CAD or a QIF file from the data package to automate the CMM programming there, which ultimately then can carry those results via QIF into the quality management system. So it can look like sort of an overwhelming flowchart here, but compared to the chaos that we have with the disconnected processes in the current state, it's actually a huge improvement. Now, next, I really just want to focus on the supplier and how they're going to get the benefit out of this. Right? This particular project, the supplier in their first operation was to create this dovetail, which is going to locate this piece for all subsequent operations. So they were actually able to apply proper GD&T to their in-process model and use the value of QIF to automate the CMM programming. They could check this before moving it on to the next operation. If for some reason something went wrong in the creation of that dovetail feature, they can either rework it or scrap it without sending it through all subsequent operations and just scrapping it at the end. So it can save a lot of time and money by adopting model-based definition practices internally. So what were the realized benefits here, right? At a high level, the automatic generation of a bill of characteristics and populating a first article inspection form directly from the CAD product definition model, that was a huge time saver. The characteristic identifiers then persisted through all of the subsequent processes. By utilizing MBE and the annotations, I say PMI here, that means product and manufacturing information. Apologize, I actually probably should introduce that term earlier, but that's an industry standard term for those annotations that are associated to the geometry. By utilizing that, the suppliers were able to use the CAD file to actually produce their manufacturing processing parts. I didn't really mention it on this previous slide, but embedded in here is the actual OEM's product model. And so they designed their in-process models around and by referencing the OEM's model. They were able to create internal 3D PDF operation sheets. And so they actually created operation sheets of all of these in-process models, which removed a lot of manufacturing process ambiguity. And then, there is somewhat of a lag in the CAM software world to be able to leverage the machine readable annotations, but we do recognize there's some potential to utilize that in improving the machine programming time as well. CMM programming, in this particular case, the supplier experienced a 30% CMM programming time savings. As with any project like this, there were some interoperability issues between the CMM programming software and the actual machine, but we identified those, and these are not numbers that I made up. These are actually directly from the supplier here. They actually felt there's a potential to achieve a 70% or greater reduction in CMM programming time, which is pretty profound because this particular supplier, it's very much a strategic initiative to leverage CMM machines much more because it just makes sense. So in summary, MBD stays connected, and it really enables the digital thread. Right? This machine-readable data can move throughout the process using MBD, and QIF very much enables this machine-readable data's consumption and quality and inspection. So that concludes my presentation today. I just as sort of a footnote, I obviously focused on CMM. That's just one type of metrology equipment out there. Right? There are other technologies that we really would like to have, such as CT scanning, all types of scanning. And there's software, the software for these types of machines and inspection technology are really, I think everybody could benefit from those applications becoming QIF enabled. So one of our goals here is to really get QIF much more widely implemented out in the market so that everybody can reap these benefits, not just people using CMM technology. So finally, if you're interested, consider our 3D CIC conference. And
now,
that's all. Any questions?
real quick, Ryan, the QIF, is that open source?
It is. It's and I'll send a link to the QIFstandards.org website, but it's an XML-based standard, right? You can download the XML schemas, and yes, you can utilize the QIF standard for whatever purpose you may need.
Great. Now, so right before we get into some question and answer, I want to give Ryan a second to catch his breath. I'm going to put a poll out. We're just interested to see how many people have looked at or are utilizing model-based definition right now. And some of you might be interested in how many other people are looking at this. So I'm going to launch this poll, give it about a minute. Okay. Okay. Those results are actually fairly surprising for me. All right. Thank you for everyone's feedback on that. Let me share this poll real fast. Yeah, it looks like we have a full equal spread from having started looking at it to having piloting it to implementing it. So that's a much different breakdown than I had expected. I think a lot of people here at DCS would probably agree with me.
Yeah, that's a pretty diverse crowd. Pretty evenly dispersed.
Okay, let's hide this. All right, so one of my attendees had to go. He's quite a bit ways away overseas, so it's pretty late at night. But could you just speak for 1 second on the difference between QIF standard and the STEP 242 new file format that's being worked on? Are you familiar with that?
Yes, I've had that question asked a few times. Right, Step 242 is an ISO standard for model-based definition, really targeted at consumption of model-based definition into manufacturing, and really not tied to any downstream specific discipline. QIF is a MBD derivative and interoperability framework, really targeted on quality systems, right? So it's not necessarily intended for manufacturing. So that's the main difference. QIF is really targeted on metrology and quality interoperability, and not anything beyond that.
All right. I got a couple other questions, and we have a few minutes here, so I'd like to see if we can't get to those real fast. So for those just investigating, one of our clients has asked, we're just starting to look at model-based definition, but we're having a hard time figuring out where to even start because it's such a big process and big commitment, and there seem to be like a lot of moving parts. So they ask, where do we even start?
Yeah, that's a great question. So one, the best place to start is really to define a strategy, right? You don't want to jump right into this. I kind of call it bookending, right? You don't want to just start in engineering and create model-based definition and try to strong arm it downstream into all your downstream organizations. That's not going to work. I've seen a lot of companies and a lot of people try to do that. You have to have a strategy, right? Now look for where MBD can enable digital manufacturing and enable digital quality technologies and capabilities. And then you're not just tying model-based definition to engineering, right? It actually is enabling other initiatives. Right? You don't want to just look at model-based definition as a standalone effort. Right? It has to be coupled with other efforts, and you're really talking about taking your manufacturing and quality organizations and capabilities to another level. And the second would be, scope out a pilot and try it once, right? And find the value across the entire enterprise and focus on them. You're going to run into challenges, but it takes a village. It's definitely not something you want to say, okay, here in a large company, say several thousand people, here 2 people, you guys are going to implement MBD. Right? It definitely requires building a team, and a lot of that, is what we cover in our courses there. Like you have the 101 model-based enterprise overview. Right? We get into a lot of those things where to start, and actually something I didn't even mention is one of the first places to start is just to get everybody normalized on the language. And what we find a lot is you ask 10 different people what model-based definition means, and you're going to get 10 different answers. So that's probably the absolute first place to start, is to really get everybody grounded and speaking the same language.
All right, so a little bit of education and vision. So here's a quick question. Yep. So this client says we use a PLM system for housing all of our data and for sharing our data. How does the QIF standard interact with a PLM system? Like Teams?
Yeah, I mean, with a PLM system, go ahead. Yeah. Go ahead.
Oh, sorry. Just yeah.
I would go ahead.
He just gave an example of Teams.
Yeah, I mean it's yeah. So if I go back to there's a slide I'll just go back to real quick. This one, if these links, if we think of this whole bottom tomorrow in the context of a PLM system, right? The QIF would be a derivative that we need to make sure our PLM system, that we have these associations between these different contextual data packages and models. So you would handle a QIF derivative very much like you would a step file. You need to make sure that you have it associated with the version of the CAD model that it was derived from. And then that way is, when they're linked and you have those associations in place during your change management processes, and you have the ability to add these derivatives to those change management processes as well.
All right, thank you, Ryan. I'm afraid that's all the time we have for today. It's now 12 o'clock here in Michigan, the USA. So I'm afraid we do have to close down the webinar. I do want to remind everybody that I'll be sending the presentation along with the recorded video tomorrow morning. You should be seeing that in your email. If you don't see it tomorrow morning, you can feel free to reach out to me. I'd be happy to provide you direct links or additional information. Also include some of the links that Ryan mentioned today for the CIC event and for some additional information on QIF. If you have any questions that weren't answered today or that come up later, feel free to put those in the survey or reach out to me directly. I'd be happy to either connect you with Ryan or with our support team to help with those questions. And as always, thank you so much for joining us today. We really appreciate your attendance and your interest in DCS solutions and, of course, in our guest, Ryan in Action Engineering. Hope everyone has a great weekend, and we'll be talking to you soon. At this time, I'm going to be closing down the webinar. And thank you, Ryan, once again for coming. If you want to just, if you have any sign off or any final notes?
No, just thank you everyone for attending and giving me the opportunity to talk about this. And I'll get this presentation to Ben, and feel my contact information will be on there, and feel free to reach out to me with any questions.
Wonderful. Thank you so much. All right. At this time, I'll be closing down the webinar. Please take a moment to fill out that survey. Your feedback is very important to us. All right. Goodbye.